Hello everyone. We have a question which says that a particle P of mass 1.6 kilogram, this is a particle P, it has a mass of 1.6 kilogram, is suspended in equilibrium. So the condition is an equilibrium by two light inextensible string, and the two light inextensible strings are AP and BP, and the light inextensible strings attached to a point A and B, and definitely the two strings are attached at point A and B. The string makes an angle of 20 degree and 40 degree respectively, as we can see over here, 20 and 40 with the horizontal, and definitely a horizontal. See diagram, find the tension in the two strings. So basically there are two strings, this string AP and this string BP, and we have to find the tension in these two strings, and the condition that they have given us is an equilibrium. And equilibrium means the opposite forces are equal, and when we say the opposite forces are equal, that means the opposite horizontal forces are equal and opposite vertical forces are equal. For that we have to split up the diagram into horizontal and vertical components. But before that, we should understand what the horizontal and vertical components are. I have seen most of the students have a misconception that the horizontal component is always a cos component. No, it is not like that. If this is an angle theta, then the side next to that would be a cos component of that particular force, and the opposite side would be a sine component of that particular force. And if we have an angle over here, then the side next to that would be a cos component, and the opposite side would be a sine component of that particular force. So basically it depends upon the angle, where the angle are, and based on that angle we can say that which one is cos component and which one is sine. So what I have done is that the condition is an equilibrium, so I have splitted up the diagram into horizontal and vertical component. If we talk about this tension in this AP, I have written it over here tension in A because this is A, and over here tension in B which is over here, and definitely they are making an angle of 20 and 40 degree which is over here. So we have simply split it up into a proper like a condition of horizontal and vertical condition, because the 20 degrees over here and this TA is basically representing like a force, or if we talk about a right angle triangle, this is acting like a hypotenuse. So the horizontal component, because 20 degrees over here, would be a cos component of this particular force, so this would be TA cos 20, and definitely the opposite side would be TA sine 20 degree. The same goes over here. This is tension in B. This is definitely we have to find, and 40 degree is with the horizontal, so this would be TB cos 40 degree. That means the cos component of this particular force, and this would be the sine component of this particular force. That means TB sine 40 degree. Now as we can see that we have the horizontal component, we have the vertical component, we have two horizontal components, they are opposite to each other, and we have two vertical components that are pointing upward, and one vertical component which is the mass of the particle, which is 1.6 kilogram, and to convert it into Newton we'll multiply it by 10, and that would be 16 Newton, which is pointing downward. Because the condition is an equilibrium and we have to find the value of the tensions in the two strings, so we would work out based on horizontal and vertical forces. If we just look at the horizontal, we can see over here we have TA cos 20 to the left and TB cos 40 to the right, and because it is an equilibrium condition, so they both are equal, so TA cos 20 would be equal to TB cos 40, and TA would be equal to TB cos 40 degree divided by cos 20, and dividing cos 40 divided by cos 20 would be 0.815 TB. So this is our equation 1, which is in terms of TA and TB. We would create one more equation based on the vertical component, and we can see that the two vertical components are pointing upward, which are TA sine 20 and TB sine 40. So we would add them up, and that would be equal to 16 because the condition is an equilibrium. So TA sine 20 over here plus TB sine 40 would be equal to 16, and definitely simply we could work out the value of sine 20 and sine 40, which is 0.342 TA and 0.643 for sine 40 and TB equal to 16. This is our equation 2. Now in order to get the value of the tension in both the strings, that means that to find the value of TA and TB, simply substitute the value of TA over here in equation 2 as we have done over here. So the equation 2 is 0.342 TA, so 0.342, and instead of TA we have written 0.815 TB, and the rest of the equation is same, plus 0.643 TB equal to 16. Now we have a complete equation in the form of TB. We could simplify it, and after simplification and division we could say that the value of TB is 17.4. Placing this value of TB in equation 1 over here and multiplying it by 0.815, we could easily get the value of TA, which is basically the requirement of the question, that is to find the tensions in the two strings, and we have found the value of TA and TB, which are the tensions in both the strings.